Hi guys, this is Miss Scott. So here we're going to talk about some ratios. Before we get into that, here is your bad joke. Did you hear about the restaurant on Venus? Well, the food's great, but the atmosphere is terrible. Kind of just like that joke's pretty terrible. Alright, anywho, here's just a quick rundown of what you're going to see in Chapter 6. There's a fun little foxtrot comic here that deals with some ratios. So the son here is ordering a pizza and he's getting 17 31st cheese, 109 323rd sausage, and whatever that fraction is as mushroom. And they were not very happy with that order, so he got all of the change in pennies. So yeah, if you're ordering a pizza, try to keep it simple with some simple ratios, not things like these. Fractions are pretty crazy. So yeah, we're going to be dealing with some fractions here in the first section. So go ahead and pause the video, jot down this essential question, and then we've got a few vocab words here to look at. So we're going to figure out how do you use ratios and proportions to solve a problem. A ratio is just a comparison of two numbers. And you can write a ratio three different ways. So you could write out in words A to B, so like 2 to 3 would be a ratio. You can write it as a fraction, or you can write it as A to B with a colon. Just means the word 2. So these are all three different ways of writing the ratio A to B. Now a proportion is two ratios, so two ratios set equal to each other. And we're going to look at solving proportions in this section. So it would be like A over B equals C over D, and then you could solve that using cross multiplication. The geometric mean is probably a new one, but that is always in this form. A over X equals X over B. So this is the geometric mean of A and B, and A and B are always real numbers. So like 2 and 3 or 7 and 8 or whatever numbers you're looking at. All right, so let's get into some problems here. We're going to write just some ratios just to practice this. So the first ratio that we're going to write is the ratio of the number of doors to windows for this room. So this room, I'm just in our classroom here at school, has 2 doors. So there's 2 doors in this room. And if we include the windows on the door, the classroom door, and then the window above the door, I'm going to count that as 2. And then we have a window back by my desk, so there's 3 windows. So we could write this as 2 to 3, or we could write it as 2 over 3, or we could write it as 2 with a colon 3. All right, so just pick whatever way makes the most sense to you. I'm going to do all 3. All right, let's look at this table of pet popularity. I think cats are the best, but that's just me. And we're going to write a ratio of the number of dogs to cats. So in this survey, 20 people said that they preferred dogs, and 18 people said that they preferred cats. We can simplify by dividing both of those by 2. So the simplified ratio would be 10 to 9. All right. Okay, let's get into a couple more problems here. So if you want to give this a shot and pause the video and try these 3 practice problems just to see how you're doing, go ahead and do that. I'm going to jump right in here though. We're going to simplify these ratios. So we got 30 yards to 22 yards, and then we are simply going to simplify. Simply going to simplify, you like that? All right, by dividing by 2, 30 and 22 can both be divided by 2, so we get 15 to 11. All right, let's look at this problem. Now, your units have to agree. So we have 45 centimeters, and then we're going to turn this 100 meters into, our 1 meter is the same as 100 centimeters. And then if we write that as a fraction, 45 over 100, notice 45 and 100 are both divisible by 5. So the simplified ratio would be 9/20. All right. Again, we've got a little issue with our units here. But this is actually really easy if you turn inches into feet, because 12 inches is 1 foot. So this is 4 feet over 1 foot. So we just get a ratio of 4:1. Now there is an alternative option. You could turn this 4 feet into 48 inches over 12 inches, but then still, if you simplify, these are both divisible by 12, believe it or not, it's true, and 48 divided by 12 is 4, 12 divided by 12 is 1, so either way you're going to get a ratio of 4:1. Do it whatever way makes more sense to you. Alright, let's get into solving some equations. This is going to be a little more exciting. We are going to solve these proportions. Now, probably during your middle school math years, you did something called cross multiplication, which means we can take 15 times x and set that equal to 4 times 75. So this is simply going to be 15x equals 4 times 75. And 4 times 75 is 300. And then we can solve this by dividing both sides by 15. These are going to cancel and we get our answer. 300 divided by 15 is 20. So x is 20. All right, example 7 is a little bit trickier because notice we have variables on both sides. Same idea though, we're still going to start by cross multiplying. 21 times y is just 21y. Now when you cross multiply here, we need to take 30 times the whole thing, y plus 3. So notice we're going to distribute that 30 into the parentheses, giving us 21y equals 30y plus 90. All right, now let's go ahead and get that 30y to the other side. So we'll subtract that over. The 30y's cancel, and 21y minus 30y gives us negative 9y equals 90. Go ahead and divide by negative 9, and we will get y by itself. 90 divided by negative 9 is negative 10. Okay, so that was a little bit trickier, but we can solve with variables on both sides. All right, now we're going to need to set up the proportion ourselves. We're going to look at some story problems here. We have the ratio of boys to girls on the bus is 5:3. If there are 24 girls on the bus, how many kids are on the bus? So let's set up our fraction of boys to girls. So we know that that ratio is 5:3. Okay, so if we start with this ratio of 5 boys to 3 girls, we got that set up, and we know there's 24 girls. So notice in this, girls is always the number on the bottom. So you need to make sure your proportion matches up. All right, and we don't know how many boys are on the bus, so that's what we're going to figure out first. So if that's unknown, let's call it x. Okay, so now we can solve this using our cross multiplying. 3 times x is 3x. 5 times 24 is 120. Go ahead and divide by 3, and we get x is 40. Now remember, x is the number of boys. That's what we made this proportion mean. So if there's 40 boys, and we want to know how many kids total are on the bus. So if we add the number of boys, and the number of girls, that'll give us the total. Well, we just figured out there's 40 boys. They told us there's 24 girls, so that means there are 64 kids on the bus. Alrighty, let's look at one more word problem here, and then we'll move on to some geometry problems. Alright, so we've got the length to width ratio of a mural is 5 to 12. If the shortest side of the mural is 20 feet, what are the actual dimensions? So say we've got this scale drawing, and we know our scale is 5 to 12 for this mural. We want to make sure that for the actual mural, we need it to be 20 feet tall. So if this is 20 feet, we're trying to figure out how far across it is. All right, so there's a few ways you can set this up. I'm going to do a ratio of the widths. So I'm going to make a fraction of 5 over 20 with a ratio of the lengths, 12 over x. All right. So if we do that, notice we set up our proportion here, 5 to 12, or 5 over 20 is equal to 12 over x. And there's a few ways you could set this up. This isn't the only way, but that's how I see it. So if we cross multiply, we get 5x is equal to 20 times 12, which is 240. Go ahead and divide both sides by 5, and we end up with x. 240 divided by 5 is 48. So the actual dimensions of this mural would be 20 feet by 48 feet. Which seems reasonable. I mean, usually a mural is on the side of a building, so I would agree that that would be pretty accurate there. All right, let's go ahead and turn to the next page here. We're going to look at a geometry example. So an extended ratio is just a ratio of more than two things. So you could have 3, 4, 5, 6, whatever. But we have an extended ratio of the angles of a triangle is 7 to 5 to 3. Find the measure of each angle. All right, so if we just draw ourselves a sketch here, we don't know what the actual angles are. I know it can't be 7 and 5 and 3 because that only adds up to 15 degrees. And we know these have to add up to 180 degrees. However, they're multiples of those three numbers. So if I say this angle is 7x, this angle is 5x, and this angle is 3x, we know that those three angles have to add up to 180 degrees. So we're going to take those three angles, add them, and set them equal to 180 degrees. We've got a bunch of like terms here. 7x, 5x, and 3x add up to 15x. And then if we divide both sides by 15, 180 divided by 15 ends up being 12. Now don't just box your answer and call it a day because we want to find the measure of each angle. Well, we now know our x value is 12, so 7x will be 7 times 12, or 84 degrees. So there's our largest angle. And then we have 5 times 12 will give us our next angle of 60 degrees. And then lastly, 3 times 12 gives us our last angle of 36 degrees. And if you notice, 84 plus 36 is 120, plus 60 is 180 degrees. So it's always good to just make a double check that those angles really do add up to 180, and they do. Okay, so the last part's probably the trickiest because I don't think you've probably seen a geometric mean in your math classes before. But we know a geometric mean is some number over x equals x over another number. All right, the two numbers are just what's given, so this is what we're going to plug in for a and b. So the geometric mean of these two numbers is whatever x value makes 20 over x equal x over 5. So we'll still cross multiply like usual, but now notice when we cross multiply here, x times x gives us x squared. 20 times 5 gives us 100. And to undo this, to get x by itself, we have to square root both sides. So x is going to end up being 10. All right. And I know those of you that are in Algebra 2 have probably done this, positive and negative 10. In geometry, we only consider the positive answer, so you don't need that plus minus symbol for these examples. Okay, let's look at one more example. So again, this is our a and our b in the formula. So we have 42 over x equals x over 70. All right, so if we cross multiply, x times x is x squared. 42 times 70 is a pretty big number. That gives us 2,940. We'll square root both sides. Now to square root this, you'll need to plug into a calculator. The square root of 2,940 is about 54.2. All right, so you won't always get a nice number for these, as you can see. All right, so let me know if you guys have any questions in class. Your homework that was going to go along with this is page 141 and 143. Thanks for tuning in, guys. If you have any questions or comments, feel free to leave those below, and I'll appreciate any subscribers I can get, so feel free to subscribe, and we'll see you guys next time. Take care.